Hello and thank you for joining us for the ArcelorMittal webinar with Automotive Manufacturing Solutions. I'm Nick Holt and I'm the editor of AMS. Today I'm joined by Oliver Moreau. Oliver leads the Automotive Steel Solutions Design Department at ArcelorMittal, dedicated to automotive applications. He has 17 years experience as customer technical support in the field of steel product applications. This webinar will focus on the added value of ArcelorMittal's co-engineering services and R&D capabilities, showcasing the benefits to car makers. Using practical case studies, Olivier will discuss how co-engineering with ArcelorMittal can help car makers to achieve their weight, cost and safety targets with steel. Now before we start, I'd like to remind all of you in attendance to draft up some questions which Olivier will be pleased to answer in the Q&A session following the presentation. Please ask these questions by typing them into the box in the lower right hand side of your screen. If you should happen to experience any technical issues during this session, please also type these into the Q&A box and our team here will do their best to sort these out for you. We hope you'll find this webinar stimulating and informative. I'll now hand over to Olivier to begin the presentation. Thank you.
Thank you, Nick. Welcome to all participants. So let me start with an overview of this presentation of today. So I will start by ArcelorMittal's global R&D organization to support automotive market. Then I will go into detail in our co-engineering methodology proposed to our automotive customers. And finally, I will focus on the next generation of steel grades that are in development at ArcelorMittal and how co-engineering can help our customers to achieve their weight, cost and safety targets. ArcelorMittal is the world's leading steel and mining company with a presence in more than 60 countries and industrial footprint in over 20 countries. ArcelorMittal is a leading supplier of quality steel in the major global steel market, including automotive and construction and appliances and packaging. In 2014, ArcelorMittal had revenues of 79 billion, a crude steel production of 93 million tons, and iron ore production of almost 64 million tons. ArcelorMittal has a world-class research and development and outstanding distribution networks with 1,300 researchers in a worldwide network of 11 labs, with also $259 million invested in 2014. Global ArcelorMittal is also the technology leader for automotive, with 5 global R&D labs dedicated to the automotive industry. 3 of them are in France, in Europe, and the 2 others in NAFTA, in Hamilton and East Chicago. 565 engineers and technicians are adapting still to the evolution of automotive customer needs, meaning develop new skills and solutions, improve steel in use properties, find anti-corrosion solutions, invent breakthrough products, and ensure technical services to our customers to show that steel has the best compromise between weight reduction, comfort, safety, and cost. Global R&D has also a dedicated resident engineer network, bringing technical support to customers around the world. We have 14 resident engineers in NAFTA, 12 in Europe, and also people from ArcelorMittal in Asia, with an office in Tokyo for Japan market, also resident engineer in China and Brazil. This network has built strong and deep relationships with our biggest customer and and we are working with them in committed co-engineering programs. So global R&D can provide technical services at all stages of the vehicle life. From advanced engineering to before the start of production, so that means from 6 years before SOP till the SOP, where we are in the industrialization phase, and global R&D EVI representative and processing engineer can support through stamping or joining issues, for example. But in this presentation, I will more focus on the advanced engineering and co-engineering, where we can support in the introduction of new steel grades and their industrialization and their approval, of course. This slide shows you the main mission of global R&D automotive application teams around the world. Their main mission is to develop and promote and facilitate the use of new ArcelorMittal steels for automotive applications. Activities are dealing with steel solution engineering by design optimization, facilitate the customer manufacturing, of course, like forming, joining, laser welded blanks optimization, to provide also guidelines, shop floor best practices, with a lot of simulation and experimental validations. We can, as I already said, the teams can provide also technical support, and we have also a contribution to process and product development by reverse engineering, where we are looking to the new generation of steels, keeping in account all specific requirements of automotive engineering. This research center have industrial size forming and welding equipment, with also a lot of final element analysis capability, like it's done actually in the automotive business. That was for the first part. Let's go to the co-engineering methodology, more into details. The objective of this co-engineering approach is to provide technical support for the design, optimization, and implementation of new advanced high-strength steel and solutions. Our goal is to, of course, find and propose the best compromise between mass, cost, and performance. So this co-engineering proposal is mainly dedicated to pre-projects in advanced engineering phase of the vehicle project development. It starts always by a very important non-disclosure agreement between ArcelorMittal and our customers, and it can go through body right review to forming or welding assessments through design and CAE optimization, of course. Cost analysis can also be performed with our customer teams. Let's go into details in the co-engineering methodology. The phase one, we split this methodology in 3 phases. The phase one, called body right review, consists in a preliminary mass saving assessment with identification of potential mass saving solution based on benchmark data, of course, but also based on the steel grade, our steel grade properties, and our engineered steel solution. I will go back on that later. The phase two is what we call the refined mass saving analysis based on grade and gauge optimization done mainly by numerical simulations. And phase 3 is the forming and welding feasibility assessment, where we can test different or resolve different issues regarding spring back, hot stamping, roll forming, spot welding, or laser blade blank. In the phase 1 of the co-engineering approach, ArcelorMittal proposals are based on steel grade properties. All steel grades are tested in dynamic compression and in dynamic three-point bending tests. As you can see on this animation on the left-hand side of the slide, here is the crash test we perform on hat structure in our research center equipment. This data allows a comparison of steel grades and preliminary weight saving potential, like as described on the graphs for compression and for anti-intrusion part on the right-hand side. In the phase 1, ArcelorMittal proposals are also based on in-house engineered solutions, like our S-in-motion solutions on C-segment vehicles, on light commercial vehicles, on battery electric vehicles and plug-in hybrid electric vehicles, more recently on pickup truck, and actually in progress, we are running a specific project on mid-size sedan vehicles. As an example, we described here our solution on our S-in-motion solutions on C-segment vehicle. So we achieved a very light body-in-white proposal at 255 kilograms for ICU powertrain on this segment, taking into account all new 2015 European crash requirements. And then we had this solution to two new powertrains, battery electric vehicle or plug-in hybrid. And we have shown that only 10 or 12 kilograms at maximum is enough to cope with the higher power, the higher mass of the powertrains that gives some additional constraints in the load cases and in the performance of the vehicle. In the phase 2, we are looking to the performance of the vehicle by numerical simulation to lead to a refined weight saving assessment. So we start by a crash analysis with all front, side, rear impact and specific load cases for doors, for example. So at the end of the phase 1, we need to get the CAD, of course, of the vehicle that we are working on to be able to keep the packaging constraints, for example. In this phase 2, here we need to work with the customer more closely on FEA models. So we can share FEA models with the customers, or we can use their FEA models in their engineering departments, of course. So here again, the R&D of ArcelorMittal has developed competencies on software used in crash in automotive engineering. Same approach for stiffness and NVH that are very important when we are dealing with lightweighting. So we are able to run a model analysis bending and torsion stiffness, for example, on full body in white, but also specific load cases on doors for chassis parts. As an example, here you have the structural FEA capability of one of our research center, R&D Montater, automotive applications. We have here in this research center 350 cores available on 3 clusters. That means we can perform more than 10 full crash simulations in less than 24 hours with the LS Dyna software. And now we will launch a video that illustrates this activity.
Crash test simulations allow car makers to check the performance of car designs using innovative steel solutions that save weight while increasing safety. At ArcelorMittal's research center in Montater, we run crash test simulations as a service to car makers so that we can co-design and co-engineer the car parts of tomorrow efficiently.
We see here a simulation of a frontal impact. So here we have a barrier that represents another vehicle. What we can see here is that there is a high level of intrusion using low steel grades that we see in this picture, and we also see a lot of deformation. I will show you now when we use higher steel grades. So that's, for example, we use U0 on this part, and we see very low deformation and also a reduction of the intrusion for the passenger. So we increase both the crash performance and we reduce the weight of the vehicle because this part is thinner.
These services to OEMs can begin up to 7 years ahead of a vehicle's commercial release, saving precious time and resources for vehicle manufacturers.
The fact that we can do simulation here allows us to propose and test a lot of different solutions while avoiding doing actual crash tests that are both very expensive and very time-consuming.
We encourage car makers to approach us at any time in the design process to test the crashworthiness of their designs and of our new lightweight steel solutions. Contact us to find out how you can benefit from ArcelorMittal's global R&D services.
Good. Now let's go to the phase 3, where we are looking with industrialization assessment. First, the assembly assessment, which is very important when we are proposing or dealing with a lot of advanced high-strength steel in the body-in-white structure. So here, regarding assembly, we developed a 3-step strategy for validation. The first step is the use of assessment tools that we developed to run a kind of risk analysis very quickly, so we can identify all vehicle stack-ups and define the most critical or difficult ones. Then we can, in the second step, run some numerical simulation using the software SORPAS, but with in-house or adapted data for each steel grades. And these simulations can really are really helpful to give optimized parameters in welding to get a satisfying welding combination. Then, of course, we can go to experimental validation for the most difficult ones. Regarding forming assessment, we have the same approach, an iterative approach. from expert validation to a one-step approach, to one-step simulation, and incremental simulation for more complex parts, then to very complex simulation like for hot stamping, where we have developed a thermomechanical simulation for our UZBOR 1500 product and PHS family. This technology has now been transferred to ESI company and is available in PAMStamp software for running hot stamping forming simulation. Same for spring back control with our UTIFO tool, which is now also in the PAMStamp package. And then, if needed, and especially with our customers on specific programs, we can go to experimental parts by tryouts. As an example, here we present the hot stamping feasibility assessment we run on laser welded blank drawing reinforcement, which is a very innovative solutions. We started by a detailed stamping analysis with a deeper feasibility analysis in simulation before launching the tool manufacturing, and then the hot stamping trials and the tool setup. So as you can see on the picture on the bottom of the slide, we have a very safe situation on all sub-blanks composing the laser welded blank after hot stamping. And then we went to a successful scale 1 prototyping phase with a very good geometry accuracy, checking, of course, the quenching in the base metal, but also in the weld areas. Here again, we will have a small video of the stamping trials realized and performed in our press shop.
Hot stamping technology provides many known benefits to car makers: weight reduction, better crash performance, best ductility and resistance combinations, excellent corrosion resistance, lower total manufacturing costs. At ArcelorMittal's Monterterre Research Center in France, tests are carried out as a service to car makers that want to assess how specific steel grade behaves after hot forming. ArcelorMittal also has facilities to design and test specific parts using 3G geometry, grade and gauge optimization. We also put every effort into developing our own generic solutions, such as the S-in-motion laser welded blank hot stamped door ring. Customers can take advantage of this unique opportunity to test prototype steel solutions on a small scale prior to final testing and full production, thus saving precious time and resources. Contact us to find out how you can benefit from ArcelorMittal's global R&D services.
As presented in the video, it's a very example going through from generic solution developed in-house and then adapted to the specific requirements of the customer, because you have seen the first car using this kind of technology is the Acura car in the US with the first laser welded blank drawing reinforcement. And now we have several programs on track for the adaptation of this solution. Last example is the laser welded blank design optimization that you can run in this third phase by first a blank nesting optimization to increase the material utilization rate, which is of course very important for cost reasons, and also in-house farming criteria developed for weld seam area analysis in between both sub-blanks along the weld seam. Then we can also run stamping trials. Here we have chosen one example regarding our new grade for exposed panel called FF280DP, full finish 280DP. It's a dual phase grade for exposed panels. So we run stamping trials in our press shop on very thin gauge to assess dent resistance and red-through on door panels. So on the graph, you can see that this new grade, as the graph is presenting the yield strength on the part achieved on the exposed outer panel in function of the dent resistance requirements. On the graph, you can see that FF280DP in 0.6 millimeter has the same dent resistance performance as BH, bicarbonate steel 220 in 0.7 millimeter. So the weight saving potential is huge. So to perform this or to achieve and to assess this potential, we decided to run a very big campaign. So we manufactured a door outer panel tool, which is on the picture on the left, and we stamped different modalities, FF280DP in 0.5 millimeter, very thin gauge, 55 0.6 millimeter, compared to BH260, for example. And we got a very good stamping quality, so the part is fusible, like you can see on the pictures. And we also evaluated the surface defects, especially on the door, around the door handle area, and also the red-through when you are dealing with a specific patch inside the panel. And this kind of test also can be done on a specific design with our customers. So I'm proposed to go to the last part of my presentation, dealing with the next generation of advanced high-strength steels and press hardenable steels to achieve the weight, safety, and cost targets in the future. So here I will present very recent results of our last S-in-motion body-in-white mass reduction study with this new generation of advanced high-strength steels and pressed hardened steel. So the parameter is also the C-segment vehicle body-in-white. We used our new 40-form family for cold stamping, 40-form 980, 40-form 1050, 40-form 1180, and also martensite, last martensite grade in development 2000, and also our two new grades for hot stamping, the Ductibor 1000 and Usibor 2000. We took into account, as explained before, all the major crash load cases to assess the solutions in front, side, and rear impact, and also stiffness load cases were taken into account, like global torsion bending and model analysis. Some words about this new steel grades, the 40-form family. So the 40-form family has three strength level, 980 MPa, 1050 MPa, and 1180 MPa for the tensile strength. So in the table, you have the specific mechanical properties targets. This 40-form grade have high formability combined with a high cut edge stretching resistance. They also have a very good resistance in hydrogen embrittlement. And this family is, with the high formability, we can really provide some weight saving from DP600, for example, regarding 40-form 980, and same for DP780 towards 40-form 1050, and from DP980 to 40-form 1180. And we consider that 10% weight saving can be achieved thanks to this switch. The next generation of press hardened steel consisting the Ductibor 1000 and Usibor 2000. So we have developed these new steel grades, Ductibor 1000, to provide 15 to 20% weight savings compared to Ductibor 500 used actually by laser welded blank with Usibor 1500. And Usibor 2000, we estimate that Usibor 2000 can provide around 10% weight saving compared to Usibor 1500. One of the solutions of this project, validated in crash and global stiffness, achieved a very low body-in-white mass at 240 kilograms, meaning minus 20% weight saving, compared to a baseline around 300 kilograms, which is representative of the C-segment market. This solution has the following body-in-white material distribution, with almost more than 30% PHS, 27% is potentially manufacturable with Usibor 2000, all on the red part on the body-in-white structure. We also have Ductibor 1000 combined with Usibor 2000, especially with laser welded blank application. And more than 16% of 40-form grades, 980, 1180, and 1050, as I described before, on specific parts in the different colors as explained on the body-in-white structure on the left of the slide. That represents more than 70 kilograms of new press hardened steels potential, and more than 30 kilograms of new 40-form family. This slide shows you the crash and stiffness performances obtained on that project, which are improved compared to our last S-in-motion solution with commercially available steel grades. While significantly reducing the body-in-white mass to 240 kilograms. So this new step allows us to offer 15 kilogram more weight saving potential in the new car structures. And when you look to the potential of alternative materials, it positions this kind of very light body-in-white, full steel light body-in-white, very close to alternative body-in-white made of other materials, partially, of course. Here you have the two animations on the slide giving the performance of the vehicle in front crash, ODB 40% overlap, which is very good. You see without any deformation on the A-pillar upper, for example, and also animation for the 75-degree pole crash test, which performs also very well. In conclusion, ArcelorMittal Global R&D has a long experience in automotive steels grades and in engineered automotive solutions. ArcelorMittal Global R&D has also developed FEA capabilities, simulation tools, and equipment, of course, to support our automotive customers for the implementation of new steel grades and solutions in the next generations of vehicles. Steel Solution Engineering clearly outlines the performance of ArcelorMittal next generation automotive products in terms of weight savings, but also in passive safety. And co-engineering from design to prototyping, as I described today, is the best way to assess these solutions regarding all specific requirements, providing real added value for car makers. Thank you for listening to this webinar, and I'm ready for the Q&A session, Nick.
Thank you, Olivier. That's an interesting presentation. We have quite a few questions for you here. So we will start off. Some of these refer to particular slides, so I'm assuming they want a little clarification, because I think a little earlier on we were struggling to hear. The audio quality wasn't great. But I'll start off. Questions regarding slide 14, and the question is SPOC included? So I'm assuming you want some clarification on slide 14. Is SPOC?
Excuse me, Nick. Slide 14, you said.
Slide 14, yes, yes. It's the fact that it's referenced in the question. I'm assuming that the viewer didn't quite understand.
Yeah. So could you repeat the question?
Yeah, the question is SPOC included? I'm assuming that's an abbreviation for something, but it's a little beyond me. So
SPOC, it's maybe an additional load case. I don't see the signification quite evidently.
Okay, Mark. Okay, Olivier. We'll ask the questioner just to be a little more specific about the question, so we can perhaps get a bit more clarity on that. But we'll move on to some more. We've got plenty of questions for you. This one again refers back to slide 20, and the question is the TWB pillar. Are there any light solutions together with CFRP patches? I'm assuming lightweight solutions regarding a TWB pillar.
Here we are clearly promoting our on B pillar reinforcement. We are clearly promoting our laser welded blank solution with UZ-bore 1500. Can be, of course, different gauges of UZ-bore 1500 or association of UZ-bore 1500 and Ductibore 500. Ductibore 500 is a softer material that can be used in the bottom area, like showed in this slide, to allow better energy absorption. But it's a full steel solution, of course.
And I think the question there was, together with that, the tailor welded blank, have you got any solutions that combine CFRP patches in that? So I'm assuming other materials within the structure of the pillar. I think that was the reference to the question.
Yeah, I see the question. In fact, we know that some solutions are developed with alternative materials or the combination of different materials. But here we think that we can achieve very good performances and weight savings and cost, of course, only using the laser welded blank solution, because you can really use the thickness, the gauge, the thickness of the material where it's needed. So here it's an example with one weld seam, but you can imagine, like presented on the door ring reinforcement. We can imagine also, depending on the requirements, we can imagine more complex laser welded blanks with different gauges along the part, and I think it's quite similar in terms of performance, and it's a full steel solution that can be more competitive in terms of cost, because the adding CFRP patch can also bring some additional cost, of course.
Thanks, Olivier. And just going back to that original question regarding slide 14, the question referred to small offset crash testing.
Okay.
So was that included? I think it's the question relative to slide 14.
Yes, it's a very interesting question because SORB, small overlap rigid barrier test, is a new crash test in the U.S. And it's a very severe crash test. We know, we think, in fact, it's very good for steel, in fact, because here we have to manage very high energy absorption on new parts, and we developed solutions to cope and to get a good performance in SORB for different car structures. And as I presented, we had an in-house engineered solution on pickup truck. It was the first time that we developed a specific solution for the pickup truck. And now we are working on a new project like the mid-size sedan, and we are dealing also with to get a very good performance in this new crash test, but of course looking always to very high weight saving.
Thanks, Olivier. A question here referring to your test trials and R&D centre. The question is the one referenced only in France, or do you have another one or a base in North America that can carry out these tests? And if not, are you planning to open one in North America?
Yeah, we have several, as I presented in the beginning, and we have five global R&D research centers dealing with automotive applications. Regarding the in-use properties and equipments related to in-use properties measurements, we have several research centers that are able to do it in Europe, but also in North America. Regarding the stamping trials, it's the research center in Montataire in France where I'm working, which are the most industrial size equipment. We have big press that are representative of the stamping in the press shop of our customers.
Thanks, Olivier. I'm sure the people in North America will be pleased to hear you pushing along there. We have more questions here. There's a few with abbreviations in, so I'm not sure what they refer to. Hopefully you will. Question here, do you have any GI-based hot stamping solutions in development with OEMs? I'm not sure whether you can talk about that or not, but...
GI coated, I mean? GI coated press hardened steel, that's the question?
Yeah, I'm not sure, GL or GI, I think it's GI-based hot stamping solutions in development with OEMs. I wasn't sure, I'm not sure what the abbreviation means, so...
It's GI.
GI, yeah.
It's okay. Yeah.
Oh,
so we don't have specific development in GI because we are promoting and we are convinced that the aluminum silicon is the best coating for hot stamping. So we have a lot of data that can be shared in technical exchanges with our customers regarding the advantages of aluminum silicon coating. So specifically for the product that I presented, UZBOR 2000 and Ductibor 1000, they will be aluminum silicon coated. Yeah.
Thanks.
But we can provide UZBOR 1500 GI, but we are not convinced that it's the best product. Thanks.
Yeah, I think the question was referring to, there's a clarification that it was a coating. So if we can, I think it was, yeah, HDG coated, I think was the reference there, which is clarified.
So, okay.
Another question here, and again another abbreviation, so apologies if we have to sort a little way through this. How does the YS evolve over time during stamping for the UZBOR 2000 material?
Could you repeat the question?
Yeah. How does the YS evolve over time, in brackets, during stamping for UZBOR 2000?
Yeah, so UZBOR 2000 was developed to get a higher YS compared to UZ-Bor 1500. So first, maybe I will mention that we have two different products. We have two different UZ-Bor 2000, one which is the first one which is already available. It's a high carbon grade with and we are developing a ultra fine grain version which will be available in the coming years. And the focus of these developments was to provide a higher YS compared to UZ-Bor 1500, of course, because these parts are working mainly in intrusion. So our target is 1400 MPa for the YS.
Thanks, Olivier. We've got some really good questions coming up here. Here's one for you. How does Fortiform perform in structural adhesive bonding, adhesive or cohesive failure mode in bonding, and bond inline strength?
In adhesive bonding, maybe we will note this question because I'm not a specialist of adhesive bonding, but I'm pretty sure that we have to do this test in the approval process. So we have to look at that, and we have looked at that, but I don't have any information here just now. But we can note the question. Yeah.
Well, what we will do, I mean, all the questions that we receive, whether we get time to answer them all or not, will be passed on to ArcelorMittal. So, you know, they can be passed on to the relevant person who maybe has a little more information on that.
Yes.
A quick question here for you regarding which technology offers the lowest costs in terms of process, hot stamping or cold stamping. Can you comment on that?
It's a good question and a big debate. In fact, hot stamping actually can use very high strength material. As I presented, we can also use laser welded blank technology to really adapt the gauge where we need it, adapt the strength where we need it with different products. UZ-Bor 1500, UZ-Bor 500, now we will have UZ-Bor 1000 and UZ-Bor 2000. So we will really be able to optimize the part very fine, I would say, in terms of performance and weight savings. So here, the cost, it's not the cost of the technology. Hot stampers have also worked very hard to decrease the cost, making more parts in one punch stroke, for example, which compensates the difference of cycle time with cold stamping. And I think the complexity of the part, hot stamping can provide a more complex part regarding part geometry. So it's very difficult to answer only around the technology. You really need to see or to look at the full solution because hot stamping can allow to integrate some reinforcement, for example, via the laser welded blank technology. So it is really a cost analysis to be done at the end of the solution, even after assembly of many parts, of different parts in the substructure.
Thanks, Olivier. We've got a few more questions for you before we're going to let you go just yet. But a question here: are there any? It's another abbreviation, so you'll have to work with me on this one. Are there any QMP steels in development at present?
QMP steels?
Yeah. I'm not sure. I don't know what that means. I'm not an expert on steel. I'm not sure if that's. We can get back to. We can get some clarification on that if you like, but.
Yeah, it's a big
okay.
big question where I can discuss a long time. But we have we have developments with many different metallurgical routes. So we are also looking to QNP routes, but our first family is not using actually QNP technology, but we are looking to all potential metallurgical routes, of course. Yeah.
Thank you. A question here which actually refers to the example of the dooring. Do you see any other parts, or do you see future parts and combinations like the dooring in your example being developed in the near future, maybe for other sections of the vehicle?
Sorry, could you repeat the question?
Sorry, yes. Do you see other parts like with combinations of steel, like the dooring example, being developed in the near future?
Good question. Yeah, we are looking every day for new innovative solutions like the dooring. You know that we also developed this kind of technology for front and rear rails. It's already used with steel grates for cold stamping, and now we are convinced that hot stamping is also a very good candidate or technology for the front and rear rails. Again, using the right gauge at the right place, using the right grade strength at the right place. So yes, we are developing that for different design of front rails, for example, and we can say that some of the design we proposed several years ago will come now on the market very soon.
Thank you. That was an interesting case study as well. Question here regarding what is the YS of UC board 2000 prior or before hot stamping the blanks?
Good question.
Is that one you can answer, or?
I don't have it here, but in fact it's not. I think it's quite low, like the UZ board 1501, and in fact it's not very important because you know that before stamping you hit the blanks, so you also change the YS or the mechanical characteristics of adhesive materials. So in fact it doesn't bring very important information, in fact, because you start with very hot blank and then you crunch to get the final mechanical characteristics on the part.
Thank you, Lou.
But we can't comment on that.
Yeah, well, so all the questions will be forwarded over to yourself and to ArcelorMittal, so that if any other people need to be involved in answering them, then they can get back to the questions in regard to that. Question here: what edge thinning percentage do you recommend for DP 800?
Good. It's a very technical question, so maybe I have to check with my colleagues dealing with that. Sorry.
We have a question here. This one may again need to go back, and I'm not overly clear. Regarding a customer was asking if they could stamp the new UC bore 1800, but apparently they were told no. So could you advise on that? Maybe something you may need to clarify with the questioner later on, I think, with that. That sounds like a... So the question was, could they stamp the new usable 1800 material? And the answer apparently was no. So I'm not sure on that one. And he was asking for some clarification on that as to whether that was the right answer.
Yeah. Yes, it needs clarification, please. Yeah.
Yeah, we'll pass that one. I think we'll pass that one over a little bit. I've got a couple more questions for you, Olivier. One goes back a little bit to a question earlier on about your research centres. And the question is, if there's not you obviously have research centres in France. How does the operation work if you're not based in that region? How do the clients or your potential customers operate and work with you if there's not a research centre in their region?
Yeah, in fact, as I presented in the first part, we have a network of resident engineers within global R&D. So there are people that can be in interface with our customer in the design center of the car makers. So we have people everywhere in the world, based sometimes in the buildings of our customers, and they are really making the link between the request of our customers and the R&D teams, whatever they are located in France or North America or in Europe, I mean.
Thanks, Olivier. We have time for just one more question here. The question is, when will FB800, the FB800 material be available for production?
Which material, sorry?
FB800.
FB800?
Yeah.
So actually, we have a CP, what we call a CP800, which is quite, I think, the same grade at the same level. So we have a CP800 for hot rolled application and also a cold rolled one. So these products are industrial.
Okay, thank you, Olivier. Well, we're going to bring the Q&A session to an end now. All the questions will be passed on to ArcelorMittal, so they'll be able to hopefully reply to any of those we didn't get a chance to cover. Thank you very much for everybody joining us today, and thank you to Olivier for a really informative webinar. The webinar will be uploaded into our archives and accessible in the future for all your colleagues who have not been able to attend today for the live presentation. And you can access this and all the previous webinars via the webinar tab on the Automotive Manufacturing Solutions homepage. So thanks again for joining us, and we hope you'll join us again for our next webinar. Thank you very much. Goodbye.